Alright, this is my sixth time through this, so hopefully I get it right this time. So on page 326 it talks about quadratic inequalities. This is probably the first video, so let's get going on it. This is a function that you're used to. You know it's going to result in a parabola. It's an equal sign, it's not an inequality, and you know in order to graph it you need to come up with the vertex and you need to come up with the x-axis intercepts. The x-axis intercepts where the parabola goes through the x-axis will be where y equals 0. So it'll be, you just sub in a 0 for the y and you'll find the x-axis intercepts. So why don't we first of all do it in standard form. So that's y equals a x minus h squared plus k. So we're going to create that format here out of this equation. In order to do that, we start it up like this. We give it some space. And we know that we're going to put something in here to make this a perfect square trinomial. Or if we add something here, we'll subtract it there, vice versa. I know to make this a perfect square trinomial, the value that goes here has to be half of this value squared. In other words, this value here, the b value, so to speak, is a 1. So half of that is a half, and a half squared is a quarter. So this equals x squared minus x plus 1 over 4. And if I'm adding 1 over 4 in there, I'm going to subtract it later, so minus 1 over 4. The equation still makes sense. This is a perfect square trinomial. It is x minus 1/2 squared. And I'm subtracting 6, subtracting a quarter, so that's minus 6 1/4. I'm not going to write it down like that, it's too messy, so I'm going to minus 25 over 4, which is the improper fraction that is the same as 6 1/4. So now I have standard form. I have my h and my k. So hk, or the vertex, is going to be 1/2 comma negative 25 over 4. And so to find that on here, we just go out to 1/2 and then 1, 2, 3, 4, 5, 6 1/4. So there's the vertex. Then to find the x-axis intercepts, next thing we do, find the x-axis intercepts, we take y equals x squared minus x minus 6, and we can see right away that we can factor that. That equals x minus 3 times x plus 2, and that means we have x equals 3 and x equals negative 2 as my x-axis intercept. So 1, 2, 3, and negative 2. Told you we were going fast, and so this is what my parabola is going to look like for that particular function. So now that we've created that function, that is where we have a good old equal sign, and it's really easy. A quadratic, if I could remind you, a quadratic equation is ax squared plus bx plus c equals 0. Equals 0 is the key here. So it's always got to be that stuff equal to 0. A quadratic inequality, same junk, but it's greater than or equal to 0. Or it could be less than 0, or less than or equal to 0, or greater than 0, or whatever, but it's not equal to 0. It's somehow different from 0. So the difference between these two leads us to a couple of things with respect to this graph. If we rewrite this as a quadratic inequality, we could write it as x squared minus x minus 6 is greater than 0, or we could write it, for the sake of argument, x squared minus x minus 6 is less than 0. And in both cases we're asking the question, we always ask the same question, what x makes y greater than 0? That's what this one asks. And this one asks, what x makes y less than 0? That's all that they do. So when you look at a quadratic inequality, ask yourself, what x's make this thing true? What x's will result in a y less than 0? What x's will result in a y greater than 0? To answer the question, you can look to the graph, because there are separate regions here on the graph. This is where x makes y equal to 0, and this is also where x makes y equal to 0. So there's this region here, the x's in the pink region all make y greater than 0. If I have an x out here, my y is up here somewhere, or if I have an x over here, my y is up here somewhere greater than 0. In this red region here, any x in this red region will make y less than 0. So if x is 2, y would be down here. If x was minus 1, y would be down here. So in the red region, x makes y less than 0. So when we look at an equation like this, I'm going to make this call that our pink equation. And this will be our, or it's not an equation, inequality, or y inequality, or sorry, red inequality. Any x's that are greater than -2 and less than 3 will make this true. So x has to be greater than -2 and it has to be less than 3. And for this one, x has to be less than, down here, less than -2 or greater than 3. So x has to be less than -2 and it has to be greater than 3. So we will probably stop ever looking at parabolas when we deal with quadratic inequalities, because really all you need to look at is this number line, the x. All you have to do is ask yourself, okay, if x makes y equal to 0, we can define these 2 points, and we've just got to test the values in between and the values on the outside, and we'll figure out what makes these things true.